All right. It looks like I won't say a majority. The plurality of y'all knew the correct answer. It actually was it was 13. Oops, sorry, I didn't share the results here. Sorry about that. So it was 13. So congratulations to those who guessed correctly or whatever. Anybody know what the minimum number is? The smallest number of goals scored to win the Golden Boot? Filippo nailed it. Hey, for time, I'm gonna give Filippo the award here, right? So, I wrote down the year and then I threw it away. Yeah, so it was quite a few years ago. A player won the Golden Boot scoring 4 goals. All right. Well, I am excited to move on here. I'm going to go ahead and introduce our first speaker. Brian Burke is the founder of the popular website Advanced Football Analytics. He's one of the early pioneers in football analytics. Before entering the world of sports analytics, Brian was an officer and aviator in the U.S. Navy, serving as an FA-18 carrier pilot. He flew combat missions. He was awarded the Air Medal, the Navy Commendation Medal, and numerous other commendations. Thank you for your service. Brian graduated from the U.S. Naval Academy before earning a master's degree in operations research from George Mason. Brian joined ESPN as a sports data scientist in June of 2015, and he's a member of the Stats and Information Group's analytics team. He designed the pass block and run block win rate metrics, receiver tracking metrics, and other models based on player tracking data. He began his website back in 2007, where he pioneered other metrics like expected points and win probability, which remain as pretty commonly known tools in the analytics world. Brian has contributed to the New York Times, the Washington Post, Slate, and other outlets. He's a regular speaker at the MIT Sloan Sports Analytics Conference. That's where the famous people go. This is where the real people go. And he also previously worked as a consultant for multiple NFL teams and supplied stats and analytics to NBC Sports, ESPN, the magazine. I'm really, really happy to have basically a big shot here speaking today. So Brian, I'm gonna let you turn your video on or to share your screen, whatever you need to do. I will mute myself, but for everybody here, please, even as the talk goes on, put your questions in the chat because I'll moderate at the end and help kind of sift through those and throw those to Brian. Because I know being the speaker, it's awkward because you've got your screen sharing and all that. So please use the chat, but also please stay muted, and I'm going to turn it over to Brian here. And Brian, you're muted.
I am.
There we go.
Thank you, Russ. Thank you. Appreciate the introduction. I really enjoy doing things like this. I regret we can't be in person, so hopefully in future years I can come out to Iowa and we can all meet in person. So what I thought I'd do this morning is kind of roll through sort of the history of what I'll call modern football analytics and just kind of walk through kind of how it all developed, how it came to be, and then finish up with a presentation on our latest and greatest effort with player tracking data. We call it the receiver tracking metrics, and I'm really excited about these. We just unveiled them this season, and I'll walk through how that came together. I do have a lot of slides, so I'm going to try to go pretty quickly and leave time for questions. So here we go. Let me share my screen. And okay, you should be seeing my screen now. And
yep, looking good so far.
All right, good. This is always the most precarious part of the event, right? It will not let me go full screen. There we go. Okay,
so hang on.
I need to turn off that. Yeah, hold on.
Well, and what we're seeing is your, oh yeah. You might, if you want to stick with that, that'd probably be fine too.
Okay.
Oh, there we go.
Here we are. Okay, so that's me. I'm Brian Burke. Yeah, I used to be in the Navy. I got out of the Navy. I was kind of bored and decided to change the way the game of football is played. So I was not the first person to come up with a lot of these concepts. It really began with a quarterback named Virgil Carter, who played for the Bengals. He played college BYU. He was a great player, but he injured his throwing shoulder kind of at an unfortunate time just before arthroscopic surgery became common. And it shortened his career, unfortunately. So back in the day, and this is in 1970, during the off season, football players had to find jobs and do other things. They weren't really paid that much. They would sell cars or insurance and the jobs like that. Virgil was very bright. He went to graduate school. He studied operations research and at Northwestern, and he co-authored this paper with an instructor called Operations Research in Football, where they posited the concept of score expectancy, and they had a very rudimentary example of this, and it had assumptions and things. They had very little computing power, very scarce statistics. They could only do it for first downs, but the idea was out there. It lay dormant for decades, and in the mid 1980s, late 1980s, group of baseball statisticians, sabermetricians, they were called at the time, Bob Carroll, Pete Palmer, John Thorne, wrote a book called The Hidden Game of Football, which kind of unearthed many of these concepts like expected points. But again, this is in an age where the data was very, very scarce, and the computing power was just not available. We didn't have kind of modern analytical techniques, the kinds of modeling concepts that we take for granted today just weren't either invented yet, or were definitely not popularly available. But it was a fun book, and it kind of kept the ideas alive. And then this is my old website. I just grabbed a sample article from years ago. I got out of the Navy, and in around 2006, I was having a conversation with a coworker of mine at the water cooler, and we were talking about the age-old concept of, does defense win championships, right? This is old kind of saying, and it's somewhat tautological, right? It's very circular. Of course, you need good defense, that helps, but does it mean more in the postseason and so on? It's a very circular conversation, and people have been having it for years. And I thought, well, wait a minute. I've got this software left over from grad school on my computer, and the data is all online now. I can go download the data, and we can answer this question by the end of lunch, right? So that's when I caught the bug, and I was like, this is really fun. And it was this old, student version of SPSS, and it was just basically box score statistics at the time, kind of team level, yards per attempt, yards per rush, and so on. And built this kind of model to explain all these things and try to answer that question. But of course, the model could do many more things, like predict games and then predict season level outcomes, who's going to make the playoffs, and so on. And this was in 2006, 2007. I decided to start this website just to mostly document all this stuff. I was doing a lot of fun things. I thought it was cool. I did want to share it, but mostly I just wanted a place to kind of journal everything. And then the website really took off. Along the way, though, we finally did have all the data and the computing power and everything we needed to finally actually build a lot of the concepts that came out of the early pioneering days. First and foremost was expected points. So if you could make an expected points model, not just for first down, but for 2nd and 1, 2nd and 2, 3rd and 7, 4th and 2, and so on, now you really have a very useful and very powerful tool to do a lot of analysis. So, for example, this unlocked the age-old run versus pass question, right? I know a lot of folks on here are probably students. You're probably too young to even realize just how dumb football analysis once was. Running the ball was essential. Establish the run. You got to run. Well, now we know, obviously, especially in the pros, that the game is dominated by the pass. Running is more of a jab, kind of, and the pass are the knockout punches. And so before that, we really couldn't. You could compare kind of yards per run and yards per pass, but then they had different kind of penalty expectations, and they had different probabilities of turnovers, and the turnovers were of very different qualities. So you really couldn't directly compare them. But now with expected points, expected points kind of gives you this kind of universal currency of every kind of, you can measure the effect of every event, any kind of event in the game. A touch, you could compare it, the effect of a touchback to the effect of a sack, right? And things like that. So, it's basically the way economists use dollars, we could use expected points to do analysis in football. So we did that. And then one of the biggest questions was, what should you do on fourth down? So back then, it was fairly universal that you would always punt or try field goal on fourth down, no matter what, unless you're just in absolute desperation at the end of the game. And so there were attempts to use expected points, and I was one of those folks who used expected points to try to answer this question. And it did a fairly good job, but nobody in the league bought on to it, because expected points doesn't consider the score and the time in the game. And those are the two most important things that you really need to consider. So although expected points kind of pointed in the right direction, what you really needed was a win probability model. And so that was the next development. And win probability model is basically a function, and it just, you input the time and the score, down, distance, yard line, how many timeouts, how good is your opponent, anything else you really need to consider. And then it will output a chance that you're going to win the game. And so you get nice, neat little functions like this. This is win probability is the y-axis, yard line is on the x-axis here, and we're down by 1 point with 1 minute to play, and you have all your timeouts. And you can notice stuff like, oh, look at the fourth down. Like once you get in within field goal range, things really change, right? You see that wrinkle there just outside the 35 or so. And so the red line is fourth down, the blue line is first down. So you can start to see these things. It's all pretty interesting. And you can make cool 3D graphs like this, and that's all very fun. And then this happened. So almost exactly, I guess this is 2008. So what is that, 14 years ago? In November of it's 2009. So 13 years ago. This is the fourth down heard around the world, and this really gave me my 15 minutes. I happened to be a regular contributor to the New York Times at the time, and I was watching this game. It was the biggest game of the year. It was the Peyton Manning Colts versus the Tom Brady, Bill Belichick Patriots. They were the two best teams of the decade. By a mile. This is Sunday Night Football, the premier viewing window for the sport. And Bill Belichick is ahead at the end of the game with a little bit of time remaining. He's faced with a 4th and 2 in his own territory and decides to go for it, right? So even if you punt the ball, logically, you can just kind of talk through it. Punting the ball to Peyton Manning with that much time, he's going to score anyway. But if you can just get 2 yards, you can seal the win. And if you don't get 2 yards, there's still a chance you're going to win anyway, right? So, but if you do the math here, and it's a simple kind of 6th or 7th grade algebra problem, or arithmetic, basically. Once you have the model, and building the model is not that simple, but once you have the model, it's very simple. And so I wrote this post on my website probably about 11 o'clock at night. The New York Times called me and said, "Hey, can we co-post this on our own website?" I said, okay. And I went to bed, and the next morning, my world changed, because this basically sucked up all the oxygen for the next 2 weeks. And so there were Sports Illustrated articles, there's long features on NFL Sunday Countdown on ESPN. Peter King was calling me. It was just an avalanche of attention and kind of media for that 1 week. And that was a turning point in the evolution of analytics in football. People, popular, my website had a following, but teams weren't very interested at the time. It was kind of confined to, folks like us, real, hardcore analytics folks. But this kind of this popularized it. And the league started paying attention, teams started paying attention. And then the next year, teams started calling me and asking me to do analysis. That was all very, very exciting too. So we could do all kinds of crazy stuff, right? Once you have this win probability model, it's like stepping into the Matrix, right? I remember the Matrix movies. You can do anything. You can ask all kinds of crazy questions. So, for example, when should you intentionally allow a touchdown on defense, right? Which is a really interesting question, which actually happens a few times each year. It even happened in a Super Bowl, which is really interesting. So anyway, that is, I would say there was the early kind of pioneering phase, and I would call that like football analytics second wave, second generation. But now we're into the third generation of football analytics, because now we have player tracking data. So there are 2 chips on each player's shoulder pads. So we know exactly where they are on the field. We know their speeds, all the derivatives you can take from that, right? Velocities, accelerations. We even know their orientation because of where the chips are on the pad. So what you're looking at here is a sack of Tom Brady to seal the end of the Super Bowl and the Eagles Patriots Super Bowl from a number of years ago. And what's happening is we're identifying all the blocks, we're identifying the coverages, and then the defenders will turn dark red when they win their block, right? So now we can measure when a block has been beaten and how long a successful block has been sustained. So that's really cool, right? Because there aren't really good metrics for linemen. They've been overlooked, but they're a critical part of the game, especially by fans and the media. But now we have really good metrics. So we have like pass rush win rate, pass block win rate, run block win rate, and so on. So that's all very exciting. I mean, at ESPN, we simplify things. So we understand our audience. Not everyone has a PhD in econometrics or something. So we just say, hey, we look at it right. We take a snapshot at 2.5 seconds, which is kind of a common logical time to do so, and break out how often somebody's able to sustain their block that long. This is an example of a survival metric. But we can do more than that. We have their entire survival curves for individual players. And we can do the same thing for pass rushers, right? So, this is an amazing, this is the Ravens of I think 2017. So if you follow pass rushers, that's an amazing group right there. Matt Judon, Tyrus Bowser, Terrell Suggs, Darius Smith, all on the same pass rush unit. Those guys are all greats for sure. I miss those days as a Ravens fan for sure. So that's the kind of thing we could do, and the story behind like how do you invent these things? Who came up with them? Like kind of after the fact, it all seems very obvious. Well, yeah, okay, you could it's quite easy to measure those sorts of things, but at the before they're actually conceived of, it's a different story. The interesting thing about this stuff was that you see all the connections, right? Between the blocks and between the coverages. The dark black line is coverage, the gray or the lighter lines are blocks. One second, pardon. So people were asking us, my team, for who was in coverage on this play, who was the nearest defender to a receiver on this play, on that play, on this play. And I really got sick of kind of diving into the data. It was a real chore and doing that. So I just built a script to just automatically do it for every play between every player. And that way I can just kind of look it up very quickly and answer the questions. And I noticed this is identifying the blocks. I was like, this is, wow, like just identifying who is blocking who and then who's getting double teamed. I thought, wow, we've never had that kind of information before. So that was kind of cool on its own. And then I realized how easy it would be to we could see when are they winning their blocks? It's just almost as simple as saying, are they closer to the quarterback than to the person who's blocking them. All right. So it's not quite that simple, but that's how simple it started out as. And so those are the kind of serendipitous kind of moments that kind of inspire kind of, these kind of creative moments. And I'll discuss another one when we have the receiver, when we go into the discussion of the receiver tracking metrics. Okay, so this is the kind of stuff, what does ESPN do with any of this stuff? So we can do a lot of fun stuff. So this is just with just the kind of stuff we did with pass rush win rate. So you can see how amazing Aaron Donald is. We all know how great he is, but now we can kind of quantify it. We can talk about things like, I think we're missing one. Oh, there it is. The Joe Thomas. So Joe Thomas retired a few years ago. He's going to be a Hall of Famer. If he hasn't already been inducted, he will be. He gave up sacks all the time on the Browns towards the end of his career. And he gave up lots of pressures accordingly, right? So he's 55th in pressure rate. But that was because his quarterbacks could not read the field. He had players like Deshaun Kaiser as quarterback behind him, and they were terrible. But if you look at him through the lens of pass block win rate, he ranked third, and this is 2017, our first season we were able to generate this. So that's an example of the kinds of things that we can do with those kind of blocking, with those line metrics. This is my next project with the tracking data. I call it DeepCover. We deep everything for when you're using neural networks for these things. But I thought that was kind of clever. And basically all it was, a lot of times we're not developing metrics. We're not actually necessarily trying to predict something, but we're trying to classify things. So we can replace a ton of human effort with automation with these models, basically computer vision. So we can watch the plays with a model, and then we can say, what kind of pass coverage was this? Was this cover 2? Was it man 1? Is it quarters coverage, and so on? So you may be able to notice the difference between these two plays. It should be animating, but it doesn't seem to want to cooperate here. Anyway, this is on the left, this is a great example of a zone coverage. On the right, it's a great example of a man coverage, but it will not let me click play, unfortunately. So you can kind of see the differences here. So in the future, you may see things like this, where if you've ever played Madden before, right? You before the snap, you can visualize what the play is going to be before the snap. And you can see where the coverages are going to be. You can see where the routes are going, what are the route combinations and things like that. So in the future, you might see a telecast, from the perspective of a Madden player, right? With the spider cam there, and a view, and you can see the actual routes. And I think it's just going to make the game just so much more understandable to the average fan. Next, I want to talk about our latest project, receiver tracking metrics that I've mentioned. And what this is we're using tracking data again to analyze every route, whether or not a receiver is targeted. And we can assess 3 different qualities of a receiver, which is ability to get open, ability to contest and make the catch, and the ability to gain yards after catch. Above what you would expect, right? So the idea here is to explain how receivers are producing, not just generate like one metric and say, oh, this receiver, he's a 91. Okay, yeah, we knew he was pretty good already. What is that? I don't care. But now we can tell a story, develop a narrative of how and why a receiver is good, or maybe not so good. Maybe a receiver has declined over the seasons, and we can understand how and why. So I think this is pretty interesting, and that's what ESPN is about. ESPN is we're not just every game you watch, every play you watch is a story. It has a beginning, a middle, and end. There's good guys and bad guys for the most part. Even if we're just showing a highlight, it's like a little story, it's a narrative. And so that's what we do, is we want to tell really interesting stories. So this lets us tell stories better with numbers. So I'm going to back up a second and talk about this project I did. I called it DeepQB, of course, deep. So we're using neural networks with the tracking data. And this was kind of a moonshot project. It was sort of like here's kind of like the early pioneers who say, hey, here's this concept. Maybe we don't know exactly, we don't have the tools exactly to do this yet, but when we do, this is going to be really neat. Right? It was kind of one of those things. And this is using neural network to kind of watch pass plays and do a bunch of different things. It would kind of identify like what players could be open. It would predict who the quarterback would throw to. It would estimate the completion probability, right? So not just for the actual receiver, the targeted receiver, but for all the receivers on all the routes, right? And so you could use a simple residual analysis, very common in sports analytics. So residual analysis is, hey, I have a model that predicts, that estimates the chance that something happens. And then if it does happen, then I credit the player with all the probability between my estimate and 1, or if he fails to do the thing that I'm predicting, then I debit him all the probability between 0 and my estimate, right? So that's a very, very common thing to do. So for quarterbacks, you could say, measure accuracy of a passer by his completion probability over expected. So that's what one of the things that this model did. And for quarterbacks, that kind of makes sense. And it's tempting to kind of flip it around in the other direction and think of it in terms of the receiver, from the receiver's perspective, right? So did this receiver catch the ball when he was expected to, or did he not make the catch? But there's a fatal flaw. There's a fatal flaw with that when you look at it from the perspective of the receiver, because what you're doing really is you're accounting for context, right? Which is a great thing. That's kind of our job, is to, we can measure these things, but you have to measure them accounting for the context of what's going on around the player, right? That's how we isolate the player's individual performance from the rest of the team. And so the problem is, the fatal flaw here is that the receiver himself is actually affecting the context. He's creating the context himself by his speed, right? By his moves, by his fakes, by his head nods, all kinds of things, right? All that receiver stuff. And so what we're doing when we do that, we say, well, how good is this receiver accounting for how good this receiver is? Right? It doesn't make sense, right? So we need something better, right? So we knew we wanted receiver metrics. We knew that was the next step in this evolution of the kind of things we're doing. And we were stuck, basically. And so we had to have a breakthrough. And a lot of times what I'll do is, when I'm developing like these super complex convolutional neural network things, I'll build a companion random forest model that's doing the same thing, estimating the same number with much simpler inputs. And that's a good benchmark and a good sanity check. It's like, hey, is this super complex model really giving me anything above and beyond what a simple model would, or how much more predictive power am I getting by using this more complicated technique? And that turned out to be the solution, right? That turned out to be the solution, so that we could actually measure the receiver's effect on that context. So what we did was, we had this very, very complicated, very powerful neural network based with the tracking data that looked at what was going on the pass route and measured basically how open a receiver was. And then by essentially saying, if this receiver were thrown to, what would be the chance of completion? And then we had a much, much simpler model that took into effect other forms of context, like what's the route type, what's the coverage type, What's the depth? You know, how late into the play after the snap is this? Lots of other things. And so that was a kind of basic context. And then the more advanced model, what I'll call the predicted, right, was the intense, very detailed context. So we had these. So basically, we took that residual analysis and took it a step further. So now instead of like comparing like expected to predicted, or comparing an actual outcome to a predicted outcome and taking the residual, now we have three different things. So we have the predicted, which is the very, very detailed context. We have the expected, which is the kind of a typical expectation. So what would a typical receiver running this route, this deep against this coverage be expected to do? And then we have the actual outcomes as well. So by looking at the differences between those three things, now we really have this answer. So it was an accident. So these breakthroughs sometimes are quite accidental. I'm going to try to finish up here by, I don't know, another 5 to 10 minutes. So we leave some time for questions. So here's an example play, just walk through one example of how this might work. So this is the first play, week 1, or first game last year. This is a deep dig, deep inside route versus a cover 4 zone. And notice we're kind of building upon previous work. So I have these other projects that classify the coverages, that classify the routes. And so we're stacking, models on top of models to be able to do stuff like this. So this is a long time in the making. Okay, so Chris Godwin, deep inside dig. And so we have to look at actually prior to pass release. We're going to take a snapshot here and measure these things, because actually by the time the ball actually comes out of the quarterback's hands, the defense has probably already reacted and starting to converge on the targeted receiver. So we can look at the detailed analysis. The predicted tells us, okay, 81.6% chance of the catch. The expected is 76.1. So the expected is like a typical receiver running this route, this deep versus this coverage, and this, lined up in the slot, so and so on. Gives you 76.1. So we credit Chris Godwin here with the difference. So openness over expected would be an additional 5.4%. And then we can do the same thing at arrival. Just in the interest of time, I'll skip over some things. So we're doing the same thing at arrival, and we're measuring ability to contest and catch at this point. We're using the same sorts of concepts to do that. And then generating yards after catch, we have another, it's a little simpler. This is a standard residual analysis. So we have a prediction of yards after catch. So we're looking at all 22 players. Is the receiver going to have blockers? How close are the defenders, and so on. And we can predict the yards after catch. So someone like Deebo Samuel from the 49ers, for example, he gets a lot of yak, but he gets a lot of yak over expected, which is a better measure of their abilities. So we have a bunch of these different things. We can kind of skin this cat in numerous different ways, predicted, expected, actuals, and things like that, looking at release, looking at it at ball arrival, and then also the yak. And then we combine those into three different metrics, which we call open score, catch score, and yak score. And then we have an overall metric as well. We adjust for a quarterback. This is quite interesting. We do it in a couple different ways. We have an adjusted plus minus model. Sometimes receivers make a quarterback look good. Sometimes a quarterback makes the receivers look good, and it's not always clear what direction that's happening in. Take Russell Wilson, for example. So I use this, it's a very common technique in sports analytics, like an adjusted plus minus type of model for quarterbacks and receivers, to kind of parse that apart. And we can tell, okay, this quarterback's helping, hurting, this receiver's helping or hurting, and to what degree. We also have video analysis trackers who watch all the games, and they score things like overthrows, or even when a receiver is technically targeted in the official records, it's a throwaway. The quarterback's obviously just trying to throw the ball away. So we can account for those things, and we don't debit the receiver for that kind of stuff. Combining all these into an overall metric was another conundrum. How do we weight all these different scores to have an overall metric to rate the receivers? Basically, what I did was fit a model of them to yards per route. Yards per route is probably the very best conventional measure of receiver ability to produce. So basically, it took these inputs here, these 7 inputs. There's actually a couple more. I think there's 9, and then fit those to a model that would estimate each receiver's yards per route, and that's gave us the certain weights. And then ultimately, openness was the most important, right? Because that's the first stage in the process. You're not even going to get thrown to if you're not open. And then the next most important was catching, right? Because you're not going to get any yards after the catch if you don't make the catch. And then lastly is yak. But for running backs, it's slightly different. Yak is much more important. I mean, they're the routes they run and their responsibilities. They're getting screen passes and so on. So this is what it looks like. You can sort of just validate the model just by looking at these receivers at the top of the scoreboard here, and you're like, yeah, those are the best receivers. So it's working to some degree. Do the same thing here, just number of top 100 seasons for each receiver, and you can see the very best receivers are up there. This is a bit of an eye chart. I won't dwell on it, but just demonstrating how it compares. These are correlation values with other benchmarks. So, Madden has very detailed, different qualities for different players. So, route running, catching, traffic, breaking tackle, and so on. And then PFF, they have game charters and graders that grade players. So these correlate very well, and in ways that you would expect. So you would have, the catch hand score correlates best with the catch contest score that our model provides, or the route running correlates best with the openness metrics and so on. So this is another way to look at it, how these different models correlate with standard conventional benchmarks. You can see PFF as a 0.91 correlation with yards per route. That's kind of absurd. So you can tell they're just looking at the outcome of the play and giving good grades based on the outcome, not really truly evaluating what's going on before the outcome. And they don't grade non-targeted routes either. So I think that's what's going on. But we're pretty pleased with what our metrics are doing. And then they're stable from year to year. This is another measure of kind of whether you're actually measuring something systematic and real. Is this consistent? Does this travel with the player across seasons? And we can see that it does. We've partnered with 538. So you can go to 538 right now, and you can see all of these numbers all the way back to 2017, if you're interested. So that's available all season. So that's it. So that's a lot, I know. So we went 52 years from 1970 up through receiver tracking metrics. So I hope that was interesting to everyone, and I'm happy to answer any questions you might have.
Awesome. So, with a virtual conference, it's always weird, how do you applaud for people? So I'm going to try to speak for the 45 people that are here. Thank you very much. Clap, clap, clap. All that.
I kept an eye on the participants number to make sure it didn't go down. So that's I'll take that as my.
Yeah, it's 9:30. You've lost 12 people already.
Right.
No, thanks. That was really good. I'll throw it out with a quick question. I know there's one or two in the chat already. What are you using to create your visuals?
The visuals. Oh,
I was just curious.
So These are just screenshots from the NGS dashboard. Next Gen Stats is what the league calls the tracking data program. And so they have like a play animation. We just call it the dots. So if you hear us analytics folks on Twitter or whatever talking about the dots, that's what we're referring to. So that's what that is. This is just, that's another example of that. The rest of this is just like ggplot.
Really? Okay. That's that was kind of, I didn't know if there was if it was a Tableau thing, if it was ggplot or something proprietary. So
yeah.
Let's see here. I see a question from Connor Heaton. Do you include who the defenders are in the analysis? Seems like they would have a significant influence on how quote unquote open the receiver got, for example.
Well, yeah. Well, I mean, absolutely. I mean, they're seen by the model. So, if you look at, I'm going to try to find one of those, something like this. So the model is a convolutional neural net that looks at all 22 players on the field, and including the defenders, knows their locations, velocities, accelerations, orientations, all of those things. And so definitely, I mean, definitely takes into consideration the defender. So you're saying, well, I know that, but are you considering the fact that it's Jalen Ramsey out there and not, some replacement level cornerback? Well, yes and no. Yes, we are, because if Jalen Ramsey is that good, then his locations, velocities, and so on will reflect that. Yeah. But at the same time, we're not considering, there's no variable in there for, is this Jalen Ramsey or is this somebody else? So,
okay. And that's, I think Connor kind of followed up. And Connor, if you want to chime in, well, he just said thanks. I think you answered his follow-up because he said, but does it know how that defender performed historically? And I think you kind of addressed that anyway.
Yeah. So, I mean, we do. But in order to do that, we have to have a defensive back version of this. And in order to do a defensive back version, you have to kind of know who the receiver is too, right? So there's a chicken and an egg problem. This is either the chicken or the egg. Right? You have to start with one. So we started with receivers.
Joel Swanson asks, how does the model handle a receiver who doesn't run out the routes when they aren't the expected receiver? I should inflect that. Maybe when they're not the expected receiver, I guess. Maybe that's the way of saying that.
Right, when they're just sort of like a decoy. No, that we don't know that. And oftentimes that's bad to do anyway.
Yeah, I think you said something about that towards the end anyway, that or maybe you said it was PFF doesn't track receivers who aren't targeted, because isn't that kind of a Pandora's box? You don't know. It's a little more unpredictable what those players are doing, right?
It's bad to do. You shouldn't do it anyway. So if it reflects poorly in your scores, then too bad. That's there's really no way for us to solve that problem anyway. One thing we do is we do not consider untargeted routes on screens. So those are definitely kind of non-route routes. Elsewhere, those will be considered routes, but we say no. You're really just probably blocking out there.
Yeah, and isn't the reality that, I mean, do we trust that every receiver is going 100% on every single play when they know they're not the targeted receiver or the primary target?
Well, the way at least at the pro level, the way it works is there are often two concepts on a pass play. One, the concept is engineered to defeat, maybe a zone coverage, and the other one on the other side of the field is engineered to be man-to-man. And it doesn't have to be that, but that's an example. And so the quarterback will usually, before the snap, read the defense, sort of predict what he choose the side of the field or part of the concept that he's going to do, and that's going to give him the kind of what his read progression will be, and then he'll go through the progression and make the throw. So the receivers don't know whether or not they really are the primary target or not until they're thrown to.
Sure. I'm going to go out of order. The next question connected to what you're talking about. Does the model factor in the difficulty of the route the player is running? For example, if a player is running a slant route in the slot versus a deep ball on the outside?
Yes, so the expected component of the concept knows the route and the depth.
Okay. Filippo asks, this is a little bit of a different question. Do you know if football players hire analytics teams to select their best free agent destination? This is something that seems to be happening in the other version of football. For example, Raheem Sterling at Chelsea with soccer.
Do the players employ analytics?
I guess maybe to determine it, is this team's offense a good fit for me?
No.
For my skill set, I guess.
No, I did, though. Their agents have contacted me in the past to ask, it help them kind of arm them in negotiations. So sure. They, let's say a kicker has a poor field goal percentage, relatively poor, but he was asked to kick very, very deep kicks that year. Right. And so you could do, a very simple residual analysis, field goal percentage over expected. And so, kickers can have a high percentage or low percentage, but compared to their depth, they may be asking more. I remember the Colts had this guy named Vanderjagt for a long, long time. And he had
as a Steeler fan, I love Vanderjagt.
Right. Yeah. And he had this incredibly, insanely high field goal percentage, but he had a very weak leg. And so they never asked him to kick deep kicks. He was always kicking, 25, 30, 40-yard kicks. So nothing deep. And so he was very overrated.
I'm okay with that. Eric asks, the Big Data Bowl this year is all about linemen. Building upon the pass rush visual you showed, are there any new lineman metrics you think could be useful that haven't been made yet?
Yeah, so I definitely you can improve on what I did, 6 years ago. It is pretty simple. It's not really even an analytics model. It's a rules-based system, but it works very well. But you can improve on it. It does have weaknesses. Here's this example. It's really funny. So this was on Monday Night Football, and we had Aaron Rodgers. Aaron Donald. We had the Rams for Monday Night Football, and I support the broadcast live, and they're all very excited because we want Aaron Donald pass rush win rates live through the game. And I'm like, you got it. This is gonna be so cool. And really early in the game, Aaron Donald, it was the most cartoonish thing you've ever seen. He picks up the guard who's blocking him and throws him back into the quarterback and causes a sack fumble, but never actually wins the block because according to my rules, the guard is always between him and the quarterback, right? And that's a sustained block according to me, right? But it was the most insane thing you've ever seen. And right off the bat, it's that counted as a pass rush loss. And so instantly everybody is like, this sucks. We can't use this.
Okay, so let's flip that. So Chris asks, how exactly do teams implement this kind of analysis in instantaneous gameplay, right? This is sort of like what you're asking. For example, do they have a brief package of scenarios with them during the game that analytically would say to go for it on fourth or punt, for example?
Yes, so this is
doing this in real time, basically.
Yeah. So one interesting thing to know is that in NFL games, teams are not allowed to use any electronics except those Microsoft tablet things. Yeah. And all those are allowed to do are look at still photos, right? Remember in the old days, they would actually develop photos during the games and then run them down to the sideline to show basically looking at pre-snap alignments. And so that's what those tablets are designed to do. That's all they're allowed to do. You can't use your mobile phone. You can't use a computer or anything. So what the solution actually came from my Navy days. In the Navy, we got computers that can do everything, but we also expect the first thing that's going to happen in the war is, right, they're going to knock down the GPS satellites, and they're going to knock out, internets and all kinds of stuff, and we're going to even lose electricity. So we have these big, thick tomes, these books full of charts and tables and things like that for your takeoff, minimum takeoff speeds, and dive angles for dropping bombs, and all, minimum altitudes for this, and all sorts of things. So, and you have like very high dimensional information. You might have like 7 kind of parameters of this thing that you need to know, and it's going to tell you what your minimum airspeed is for takeoff of the carriers. And so, we got very good at being able to convey high dimensionality in 2 dimensions on a sheet of paper. Mm-hmm. So basically, that's the solution. They have a binder. Each team has a binder, and they pre-compute all the various possible situations and different times and scores and things like that. And you can simplify a little bit. You don't need to know every single second. And so there's different teams do it different ways. I like visual, color-coded things. I think that's quicker. And they'll have a tab, and okay, we're down by 3, and I go to the down by 3 tab and look down the table, and that'll give them the answer.
Yeah, I think that, so the final question, I think Nick asked this a second ago, which I think you just answered really. Nick asked, are any of these metrics being used to help teams determine when they should go for 2 versus a PAT? And I think that's, I think it's exactly what you were just saying. Here are, whether it's color coded or, for me, I would need, I look at what these coaches have. I would need the extra big font size because I would need my reading glasses. But yeah, I'm sure they have all that in a 2D format on their sheets.
Yeah. So like I said, like once you have a good win probability model, and these are hard to build, like even like the ones that are publicly available, there's some open source ones. Towards the end game, kind of the last 2 minutes of like each half, they're garbage. They don't work. So you really have to work very, very hard to build these like very believable, very effective, very correct, very accurate models. It's really, really hard to do. But once you do that, like I said, you've kind of stepped into them. You can do anything. You can answer any question. Should I call a timeout here? What's the kind of break-even expectation of if I challenge this play? What's the probability of overturn that I would need to make this challenge worthwhile? Like you can do anything with it.
Yeah, and the challenge then also, even if it's the best model, the coach has 40 seconds to make that decision.
But here's the interesting thing: is you don't have to wait until the 4th down presents itself, or the second, or the 2-point question presents itself. So what we do to support our broadcast is we have what's called a look ahead. And so we know once the 1st down occurs, we know what every possible 4th down will look like. So we know the down distance yard line for any possible 4th down, right? So if you have a 1st and 10 at midfield at the 50, that means 4th and 1 is going to be at the 41, 4th and 2 is going to be at the 42, and so on. And we can estimate the time. We know the score is not going to change, and so so once a 1st down occurs, we can just hold up fingers and we'll just say 3. And we'll say that's 3 yards or less, you go for it. Outside of 3 yards to go, you would punt or field goal. So it simplifies things. We actually made it into like a little stoplight visual. So the broadcast crew, it's very, very easy, very, very easy for them to very quickly understand the situation, even ahead, well ahead of the 4th down. So they can say, they won't say, hey, the ESPN analytics team says this. They'll say, although sometimes you will hear Troy Aikman say green go, and what he's referring to is the stoplight thing. But he'll say something like, they can run the ball here on 3rd down because they're in 4 down territory. Like that makes them look smart, makes the analysis better, but you don't have to bore the viewer with all kinds of like numbers that nobody wants to hear about.
Right. And there's so much machinery that leads to that, that leads to Troy Aikman saying green go.
Yeah.
All right. Well, I think that's probably a good place to stop. We're actually over a couple minutes, which is perfectly fine. Let's thank Brian again, put something in chat, put the little clappy icon up, whatever you want to do. But Brian, thank you so much for, a really fascinating look at some of the work that you do and continue to do. and the things that we see, you know, each week on Monday Night Football and other broadcasts. So thank you so much.
Yeah, thank you, Russ. Thanks for having me. I do enjoy these things, and I look forward to seeing folks in person in the future if possible. So thank you.
Awesome. I think